So window efficiencies, we talked about this already a little bit, but so there's a lot of confusion for the U.S. manufacturers. Again, there's really no direct correlation between your NFRC values and your ISO values. There's several reports out there that compare them, but the conclusion is, sorry, there's no direct conversion. So when we put the language in the spec, we put the direct language to the ISO EN standards that are required, the values that we need, and we give them, we've got some contact information too for somebody who can actually do that conversion for them. So they're not in the US, but they can do a modeling exercise, produce these numbers for the windows, and it's really not, it's not thousands of dollars. I think it's a few hundred. So that's something this is going to be rectified soon. We've had so many American manufacturers aggravated with us and frustrated over this. They're going to just fix it soon. They're all going to have the values that you need, and it's going to be done. I think a lot of them can't meet the frame requirements is the problem. There's not, especially if you're looking at an aluminum window, the American manufacturers don't have a good enough frame. The glass you can do, but the frame is not as good as we need it to be. So that's part of the problem. So yes, you're going to be ordering from Europe most likely, or Canada. Yes?
Quick question. Could you explain briefly why the NFRC and ISO value are different?
Sure. The question was, why are the NFRC and ISO values different? When they do the calculations, they use a different size window. They use a different thickness of the space between the glazings, and they use different design conditions for, I think, interior and exterior temperatures. So there's all these different components in the modeling that they do. That's why they're different. If I missed anything, please chime in on that. But and just I know just to give you guys an idea of the window values that are available now, you can get easily R11 glass center of glass, R11 easily now. All of the Passive House suppliers, it doesn't have to be a Passive House certified window, but all of them that work with Passive House projects can easily get you that glazing. The frames you're going to find, the worst one I think you're ever going to want to use in this climate or be able to use because of temperature and condensation problems is probably around a 0.28, and that's really pushing it. You have to use a really good glazing with that and watch how you install the window. But you're probably going to want to keep your frame down in the U value of 0.2 or under. Okay, that's where you're going to aim. That's just a guideline. It's not set in stone, but just from what we've been dealing with certification and the products that are out there. And I can't give you product names during this, but I can afterwards. I'm not allowed. Overhangs. So because overhangs are not typical on these projects, it makes shading difficult. What you can do is, if you have any thickness to your wall, is actually set your wall back in the space towards the inside. And even that, if you can get 4 or 5 inches around your window, that helps a lot. You'd be surprised. You can also do, the recessed porch type of a thing where you have stacked porches that will help shade at least some of the glazing. So, you guys are the architects. I'm not going to tell you how to come up with creative solutions. You come up with a dozen more creative. I'm an engineer. I do numbers. So this is really an issue, and they look at this because Passive House looks at the percentage of the year of the season that you're going to be overheating in those spaces. Now, everyone in the city will likely have cooling because they have to be able to close their windows for noise and all of that. But when we take that equation, when we take cooling away, we look at, okay, how much of the year would they overheat? And if they want it down under 10%. I don't think it's really that possible for these buildings. I just don't. I haven't found a way to do it without, but they certainly don't want to see you in the 40s and 50% overheating range. So you'll just have to work back and forth with your consultant on what the best strategy is to try and reduce that overheating factor. So the solar heat gain coefficient, as I mentioned before, you're going to find a balance between the cooling and heating. If you go too low on the solar heating coefficient to try and get your cooling down, then your heating starts to bump up because you're not getting the beneficial radiation in the winter. And then you'll see So you look at those three numbers, you make a little change, you go back, look at those three numbers. And so at the point where your primary heat demand doesn't go up when you change that solar heat gain coefficient anymore, that's the point where we want to hold it, right? So there's going to be a point where you bring it down, bring it down, bring it down. Your heating's going to start to go up. Your cooling's going to start to come down. You've got to watch that primary energy demand. And where you find that levels out, that's your solar heat gain coefficient for your project. It's very fun.